Welcome, ladies and gentlemen, to the free response question review. In today's episode, we will be discussing the 2012 Calculus BC FRQ, question number 5 from the non-calculator portion. This problem was also guest appeared on the 2012 Calculus AB as well. It is a typical differential equation, and we will answer a bunch of questions on it. Now, before you get all freaked out on the BC side about whether or not this graph looks logistic, it totally does look logistic, and because the graph is. But don't worry about that. They're not going to throw logistic growth to a Calculus AB student, so don't get freaked out and think, oh my gosh, am I going to have to use partial fractions at some point? That would definitely not have been fair for the Calculus AB students. So we just tackle this thing as is. The problem reads, the rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight at time equals 0. The bird is first weighed, its weight is 20 grams. If B of t is the weight of the bird in grams at time t days after it is first weighed, then dB over dt equals this thing. So this is where the problem on the board begins right here. It begins right here with this differential equation, which is a model of the rate at which this bird is gaining weight. And so we're going to have let y equals b of t be the solution to the differential equation with the initial condition b of 0 equals 20. So part A, it says, is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Explain your reasoning. So we want to find out the rate at which the bird is gaining weight. So for that, we need a derivative. Luckily, we are given one. So part A is pretty straightforward. dB over dt. What I'm going to do is I'm going to go and find out how fast the bird is gaining weight when b equals 40. Well, that's going to be 1/5 times 100 minus 40, which will be, looks like 60 over 5, which is 12. And then I'll go and find out how fast the bird is gaining weight when b equals 70. Well, that's 1/5 and then 100 minus 70, which is 30 over 5, which is 6. And then from here, I can use that as a justification in the end. So what I can do is I can go ahead and say the bird is gaining weight faster, move them up a little bit, when b equals 40. And that's because, and I'll go and write the rest of it, and that is because dB over dt when b equals 40 is greater than dB over dt when b equals 70. So pretty straightforward, part A. We just had to figure out how fast the bird was gaining weight when it weighed a particular amount, so nothing really too crazy right here. Part B was probably one of the more infamous parts of the problem. It said find d squared b over dt squared in terms of b, and then it said use something we'll worry about him in a second. But let's just go and find the second derivative of this thing. So remember, dB over dt is equal to 1/5 and then 100 minus b. So if I'm going to take the second derivative of this thing, they said in terms of t, so that's going to be d over dt here. Now from here, the left side is pretty easy. He becomes d squared b over dt squared. Now from here, I'm going to go and kick the 1/5 out and go ahead and derive the 100 minus b. That's going to be negative. Now here's where people are going to make their mistake. They think that it's -1, but it's not -1 because they see the derivative of a singular variable. But remember, you're not doing d over db because that would be 1. You're doing d over dt of b or negative b. So you get negative dB over dt, which then gets you, if I really want to simplify this thing, and I really want to simplify this thing, you get negative 1/5. I just kicked this negative outside here. And then you get an additional dB over dt, whatever this guy was in the beginning. Well, what he was this guy. So an additional 1/5, 100 minus b. So what that gets you is it gets you negative 1 over 25, 100 minus b. So that is the second derivative. So we've earned half the points for part B already. Now it says, use d squared b over dt squared to explain why the graph of b cannot resemble the graph. So, kind of a confusing question, but let's take a look at what we know here. Well, if we look at the graph that we are given, this logistic-looking graph, the S-curve, for anyone who's in Calc AB who doesn't know the logistic graph, it's this thing that looks like an S. Let's look at the graph here. Well, remember, the weight in grams, that's B. The time in days is T. Our second derivative, which measures concavity, has only for an input, it only has B, which means I'm only plugging in these values. I'm only plugging in these values here to find out what my second derivative's value is. Well, in between the values in question, I'm between 20 and 100, which means that's all I can plug into B. And if all I can plug into B are numbers that are between 20 and 100, what that tells me is that this piece here is always positive. The inside piece is always positive. But what does that mean for the piece in its entirety? Well, the piece in its entirety, if I have a negative times something always positive, that means that I'm always negative. In other words, my second derivative is always negative, which means B is always concave down. Now, if you look at this graph, which is B in terms of T, this graph is not always concave down. Right here, we've got concave up, which is why the B graph that we actually are supposed to be graphing cannot be this. So this is a big bad no. There's no way that our graph could be represented by this S-looking curve. So we just have to put that into words, which we kind of already did. So we can say then that I'll have to write out the first part of it. I'll have to say d squared b over dt squared is always less than 0 for all b in between 20 and 100. And then we can say, therefore, b must always be concave down, and therefore cannot be, and I'm going to run out of space here, represented by the, I'm running out of space, the given graph. And I apologize, I ran out of space there just barely, but again, let me just reread this. It says d squared b over dt squared must be less than 0 for all b in between 20 and 100. Therefore, b must always be concave down. Therefore, cannot be represented by the given graph. So I apologize for running out of space. If you need to, go and just rewind that and hear me say it 500 or 700 more times. I apologize again. Part C, I will go ahead and do. Pretty straightforward for part C. It says, okay, now that I've gotten the board all clear, let's go and take a look at part C. It says use separation of variables to find b of t, the particular solution, with the initial condition b of 0 equals 20. Okay, we can do this. We've done this several times, so please make sure we are separating terms appropriately. So from here, if we separate terms, I'm going to move this dude over. I'm going to multiply the dt to the other side. So 1 over 100 minus b dB is equal to 1 dt. When I integrate both sides, I'm going to easily, on the right side, get t. Please don't forget plus c. If you forget plus c, the problem pretty much dies. And right here, I know what you're thinking. Easy. It's ln of 100 minus b. Pretty straightforward, right? No. There's actually going to be a negative hanging out here. Now, if you're wondering where this negative came from, it came from the reversal of chain rule of this negative b. If you need to use sub the 100 minus b, and you'll see it happen, where if I derive this ln one more time, I'll need a negative to cancel out the negative chain rule of the b. So please make sure you don't make that mistake. A lot of people are going to make that mistake. Remember, this test is just as trained as you are. It knows where you're going to make mistakes. The writers know where you're going to make your mistakes. Please don't fall for it. From here, my personal style is I'm going to just go and multiply everything by -1, so I get ln of 100 minus b in absolute values equaling -t plus c. I do not like to solve for b as long as this absolute value is still here. I like to get this in exponential form, so let's go ahead and do it. That's going to be absolute value of 100 minus b equaling e to the -t plus c. I'll go and just do this one step at a time just so that we can see all this happen. 100 minus b is equal to e to the -t times e to the c. Again, just a reverse engineer of my exponent rules. This guy is going to become c e to the -t equaling absolute value of 100 minus b. Now on the side, I'm going to say that plus or minus c equals c. And then I will go and just keep on going. So I will go ahead and say 100 minus b equals c e to the -t. Now from here, I've been neglecting my initial condition, but I got to remember that b of 0 is equal to 20, and that's how I'm going to solve for c. So I'm going to say 100 minus 20 is equal to c e to the 0. So c equals 80. So you end up getting 100 minus b equaling 80 e to the -t. Flop some stuff around, and you end up with 100 minus 80 e to the -t equaling b, and you're done. That's as far as you need to go for this problem. And I believe that will wrap it up for this FRQ here. So if you have any questions, as always, please leave them in the comment section, and I will see you in the next episode.